Welcome students. In this session we are going to study blood pressure measurement. In last session we were studied, that is temperature measurement. Okay, but here we are going to study blood pressure measurement. Okay, so first of all we are going to see what is blood pressure, why we need to measure blood pressure. Okay, so first one is the blood pressure indicates your heart health. Blood pressure indicates heart health or heart performance. It is determined by contraction of heart. Blood pressure is based on the contraction of heart. Okay, right? So your pressure varies depending on the condition of your heart and blood vessels. So pressure varies depending on the condition of heart. Okay, suppose the heart is weak, means blood pressure is very low. Even very old persons having low blood pressure. Okay, there is very low blood pressure lead to heatiness. Okay, right? So the blood pressure is very important. So the blood pressure that indicates a heart performance. Okay, then pressure is measured in millimeter of mercury meter. Okay, so millimeter of mercury, that means mmHg. Okay, the blood pressure is measured by mmHg. Okay, see different diagram. Okay, so this is a blood pressure measurement instrument. This is huff. This is a the bulb that is used to increase the air pressure. Okay, so this is a mercury scale. Initially it is n0, so whenever increasing the pressure, so the mercury level is increased. According to the different levels, we are measuring blood pressure. Actually we are measuring two blood pressure. So how to measure and what are the points are used here and the procedure to measure the blood pressure, these are things we are going to study. Okay, let us enter into video.
U.com.
What is blood pressure? What is blood pressure? Generally pressure. Okay, blood pressure is a force that blood exerts against blood vessels walls. Okay, so it is a force exert against blood vessel walls. Okay, see the diagram. So this is a vessels. Okay, so over the vessels, the walls of the vessels, and the blood force the walls of the vessels. If cut the one, the blood is distributed very long distance. Okay, right? So the pumping action of the heart generate the flow. Okay, the pumping action of the heart that generate the flow. The pressure occurs when the flow is met by resistance from blood vessels. Okay, see, consider one water pipe. The water is normally flowing. If you just press the pipe, what will happen? The pressure increases in the pipe. The same concept, the heart is pumping the blood is flowing through the vessels. When we are disturbing the vessels, the blood pressure is increases in the particular vessels. Okay, so based on this concept, we are measuring the actual blood pressure in our body. Okay, right? So pressure occurs when the flow is met by resistance. Okay, the pressures due to some flow resistance. Okay, from blood vessels walls. Okay, that is a blood pressure. So laminar flow, what is that? Blood flows faster in center of the blood vessels. Okay, blood flow is faster in center of the blood vessels and very slow in outer area or the walls, near walls of the blood vessels. And generally when river is flowing and the water flow speed is very high in the center of the river, in the edges, both the edges, the flow is very slower. Okay, the same concept. Okay, because the blood near the sides are hitting the walls of the vessels. Okay, So the bloods containing different elements, that is a blood plates. Okay, so these are also flowing around with liquids. Okay, blood liquids. Okay, so these plates are making some friction over the walls of the blood vessels. Okay, so it caused by the friction, that is the resistance between the blood and vessels walls. Okay, so that creates some pressure. Okay, blood pressure graph. By taking your pulse, you can feel that blood pressure fluctuation with each heartbeat. Okay, so the blood pressure is fluctuated between each heartbeat. The pulse which you feel is actually a pressure wave that travel from your heart through your arteries. Okay, so you can see the pulses like this. Okay, we can you can find your pulse just placing your hand in your hand like this. Okay, so in this way you can find your uh, pulses. Okay, the pulse in the sense that is a wave. Okay, so the wave that is traveling from the heart. Okay, pressure wave that is traveling from the heart through the arteries. Okay, so this is a blood pressure. See, the systolic pressure is the maximum pressure. So actually this is a systolic pressure. Okay, in the maximum level. Systolic pressure is the maximum pressure exerted by blood against the artery walls. Okay, so that is a systolic pressure. It results when the ventricles contract. Normally it measures 120 millimeter Hg. Okay, so systolic pressure means the heart ventricles are contracting. Okay, the heart ventricles are contracting, so that time we have a feel more pressure. That is the highest pressure, that is a systolic pressure, that is around 120 mmHg. Okay, right. Next one, Tricrotic Notch. Okay, so Tricrotic Notch represent the interruption of blood flow due to brief backflow of blood that close the artery similar valve when the ventricles relax. So initially ventricle contract, at the time we are measuring this systolic pressure. So after that the ventricle is relaxed, at the time the valves are closing, so some amount of blood is flowing backward. Okay, right. So backflow, that backflow creates small notch, that is called Tricrotic Notch. Okay, right. Next one is the diastolic pressure. Diastolic pressure is the lowest pressure in the artery. So it results when the ventricles are relaxed, and it's usually around 80 mmHg. Okay, so 120 mm is the highest, 80 mm is the lowest, that is a diastolic pressure. Okay, so in diastolic the ventricles are relaxing condition, in relaxed condition. Okay, then blood pressure sounds. So why the doctors are observing some sound from measuring blood pressure? So there is a sound that is present when we are measuring blood pressure. A cuff is inflated to constrict and artery so that no blood flows. Okay, what is cuff? So cuff is when measuring blood pressure. So the doctors or nurse placing one layer, that is called cuff, over this arm. Okay, right. Then as the cuff pressure is slowly released, so initially the cuff is empty. After that they are increasing the pressure by filling air by pressing the bulb. Okay, right. So when the pressure is high, so there is during the high pressure there is no blood flow during the arteries. Okay, so then initially blood pressure is the air pressure is high, at the time there is completely it's constrict the artery, so no blood flow. After that they are slowly releasing the pressure. Okay, but the artery is still partially constricted, the blood flow begins again. So sound will hear because the blood flow is causing audible sound. Blood flow is flowing slowly, so the time it creates some sounds. Okay, when the artery is fully open, the blood flow is freely flow, and it is completely flow, the blood is fully flow through the artery, there is no sound. Okay, so the sound will disappear. Okay, so when we are releasing the pressure, at the time the blood flow is started. Okay, so usually we can see that if your water is flowing, you just press the pipe, so it will, the pressure is increased, and it will make some sound. Okay, same way the blood is flowing through the arteries, that creates some sound. Okay, that is a blood sound, the blood flow, blood pressure sound. The first sound that are here, that is indicated as systolic pressure, the top number. So when we are releasing the pressure, the first sound is here, that sound indicates a systolic pressure, that is a highest pressure 120 mmHg for normal person. When the sound stops, that is indicates a diastolic pressure. So in this case the blood is flowing freely, so there is no sound. Okay, so that is a bottom number, that is a 80. The average blood flow is 120 by 80. It's for normal human. Okay, so this is a blood flow graph, no need for okay, right. Then indirect method of blood pressure measurement. Okay, here we are going to study the methods, direct method and indirect method. First we are going to see the indirect method of blood pressure measurement. So that is also called as non-invasive measurement. Okay, non-invasive measurement. Okay, see the diagram. So we are having the arteries in our hand. So most of the time, and the doctors are the old doctors are finding the pulses by pressing this area. They are pressing the arteries. Okay, right. So artery, the branchial artery is the most common, okay, common measurement site. Okay, measurement site. So that is common measurement site, that is very close to heart. Okay, convenient measurement. Okay, that is a forearm, radial artery, wrist. Actually this is a forearm, it's a wrist. Okay, so then you have much higher SP. Okay, right. Systolic pressure, here we can feel higher systolic pressure. Okay, when you are press some seconds, so you can understand the highest systolic pressure. The most common indirect method are auscultation method. Okay, auscultation method and oscillometry. An occlusive cuff is placed on arm and inflated to the pressure is greater than systolic pressure. So pressure is greater than systolic pressure, then the cuff is deflated gradually and measurement of blood flow is done. Okay, so this is a normal method, the direct method. Okay, right. Then the occlusive cuff. Okay, occlusive cuff should be on the correct size in order to transmit the pressure to artery eventually. Okay, and thus to obtain the accurate results. A short cuff requires special attention in placement. Longer cuff reduce the problem. So the cuff should be placed at the heart level in order to minimize hydrostatic efforts. Okay, actually in direct method they are using the cuff. Okay, actually in our doctors measuring the blood pressure based on the direct method by using cuff and mercury meter. Okay, right. So this is a monometer. Okay, monometer. So actually here we are using the very smaller lean cuff. This is a air source, that is a bulb. Okay, here this is a mercury meter, here this is a mercury scale, here we can measure the mercury levels. Okay, palpatory method. Okay, so palpatory method is the oldest method. So they are measuring the blood pressure for some time. They are measuring the pulses. Okay, pulse measurement. Right. When the cuff is deflated, there is a probable pulses in the wrist. Okay, so the pressure equal to blood pressure. The several measurements should be done as the respiration and vasomotor waves that modulate the blood pressure levels. Okay, right. So this is a very basic method. Then the advantage of this basic method is, or direct method is, blood pressure can be measured in noisy environment too. In noisy environment also we can measure the blood pressure by pressing this wrist position. Technique does not require much equipment, so it's not does not require more equipments. Disadvantage is only the systolic pressure can be measured. Diastolic pressure cannot be measured, but because the systolic pressure is the highest pressure that only we can measure by using this method. And diastolic pressure is not possible because that is very less pressure. That is not possible by this method. The technique does not give accurate result for infant and hypotensive patients. Okay, so infant means the babies. Okay, for babies we cannot measure this type blood pressure by using this method is in accurate manner. Okay, right, these are disadvantage. Then musculatory method. Okay, musculatory method. So this is a diagram. Actually this line indicates a pressure level. So initially cuff pressure is maintained, that is over the our systolic pressure. Actually the highest pressure is the systolic pressure, so cuff pressure is more than the systolic pressure. So this is our mercury meter. Mercury meter shows the highest pressure, that is over the systolic pressure. So in this pressure the blood flow is stopped. Okay, in this pressure the blood flow is stopped. Okay, right. So this is our cuff. Okay, this is our sphygmometer cuff. Okay, this is our cuff. This is a hand bulb that fill the air to the cuff. So it is another index conducted with the mercury meter. Okay, right. So initially the air pressure is higher than systolic pressure. Okay, then after that this is a systolic pressure, so they are slowly reducing the pressure here by using the valve. Okay, then the pressure is reducing slowly. At the time the systolic pressure, here you are having some sound, and during this point onwards, that is the some sound is hearing, the sound is slowly reducing. When it reaches this point, okay, so the sound is disappear. Okay, so this area is called as diastolic pressure, and this area the sound initially appearing, that is called as systolic pressure. Here the sound is disappear, the point at which the sound disappear, that is called diastolic pressure. There is no sound. Okay, sound level is initially high at the time of the pressure. So at this point the diastolic pressure is very low and zero, that is we can find the diastolic pressure. This way they are finding the pressure levels. Okay, right. So the pulse wave that propagate through the pharyngeal artery, okay, generate cough sound. Okay, cough sound. There are 5 distinct phases in the cough sounds which define systolic pressure and diastolic pressure. SP means systolic pressure, DB means diastolic pressure. The cough sound are oscillated with stethoscope or microphone. Automatic in measurement they are using microphone. Okay, the frequency range is 20 to 300 hertz and the accuracy is plus or minus 2 mmHg. Okay, for systolic pressure, and plus or minus 4 mmHg for diastolic pressure. Also with this method several measurements should be done. Okay, right. Advantages of this method is the musculatory method is simple and does not require much equipment. Disadvantage is musculatory method cannot be used in noisy environment. Okay, the observation differ from observer to another observer. Okay, so it cannot be used in noisy environment, so the observation is differ from one observer to another observer. Okay, right. Then the procedure, how to measure the musculatory method blood pressure. Okay, initially the cuff is wrapped around the patient upper arm midway between elbow and shoulder. Okay, we know that about the blood pressure measurement. Then the stethoscope is placed over the artery. At this place the pharyngeal artery comes close to the surface. Okay, in this area. Okay, the cuff is inflated. Initially it is inflated. The pressure inside the bladder is increased to point greater than the anticipated systolic pressure. Okay, so initially cuff is placed and the stethoscope is placed in the artery around the wrist area. Then the cuff is inflated and the bladder is increased to point greater than the systolic pressure. Then this pressure compress the artery. When the pressure is increased, this pressure compress the artery against the bone, so that the blood flow is stopped in vessels. So the blood flow is stopped in the vessels. Then after that, they are slowly reducing the pressure by releasing the air. Then what happened? So then they are watching the mercury column. When the systolic pressure is exceeds the cup pressure, exceeds the cup pressure, then the doctor can hear some crashing and snapping sounds through the stethoscope. This sound is called as Krothoff sound. Okay, Krothoff sound. Okay. So when releasing the air slowly at the time when the cuff pressure is less than the systolic pressure, the blood flow is starting. So some sound is happened. The sound is called Krothoff sound. When the Krothoff sound is vanished when the pressure drops below the diastolic pressure. The pressure drop below the diastolic pressure. The pressure reading in the mercury column during the onset of Krothoff sound is noted as systolic pressure is 120 mmHg for normal persons. The pressure reading in the mercury column at which the Krothoff sound is disappear is noted as diastolic pressure. It is usually 80 mg per Hg for normal persons. Okay, the Krothoff sound is disappear at some point is called as muffling. Okay, so Krothoff sound is disappear at some point is called a muffling. And the use of Krothoff sound as an indirect method of blood pressure measurement, that is known as oscillation method, that is related to sound. Okay, oscillation method. So the Krothoff sound is indirect indicator of blood pressure measurement, so that is known as oscillation method. Okay, right. Next we want to see the direct method. Okay, so the indirect method produce some 90% clear result. Okay, when compared to direct method, indirect method is somewhat inaccurate. Okay, so the direct method is used when the accurate blood pressure reading is necessary. In some case, the accurate blood pressure is very important to analyze the performance of heart. Okay, to know the blood pressure in deep region, the indirect method is not possible. Okay, for example, if a normal human blood pressure, we are placing our cuff over this place. Okay, if you want to measure my blood pressure in some area in my leg or any other organ, this indirect method is not possible. Okay, indirect method is not possible. Okay, so that we are using direct method. For example, some patient, some organ not working. For example, one side is completely not working. Right hand, right leg is not working, means the doctor must check the blood pressure in the right hand and the right leg and every areas. Okay, in this case, the blood pressure measurement by using the previous method is not possible. Okay, to overcome that, we are using the direct method. So direct method is used to measure the blood pressure in normal way. Okay, right. So it is used to measure the blood pressure in deep region, that is a indirect method is not useful in this case. Okay, so probes used in direct method. So in direct method, head cutter or needle type probe inserted through the vein. Okay, they are inserting the tube inside our vein. Okay, so this is considered, for example, this is our vein, means they are inserting very small tube, that is called head cutter. Okay, head cutter that is inserted through our vein. Okay, the head cutter tip probe. So it has two types. One is head cutter tip probe. The sensor is mounted at the tip of the probe. The pressure on the tip converted into some corresponding electrical signal. So the probe is a very small, less than one, almost 0.0 mm or 0.5 mm thickness. Normally the needle of or microtube pencil tip. Okay, right. So that is inserted through a vein. Okay, right. It is somewhat painful. Okay, the sensor is mounted at the tip of the probe. the pressure on the tip converted to the corresponding electrical signal. Okay, this is one way. The another one method is fluid filled cathode type. So in this type, the tube is filled by some fluid. Okay, so here there is no sensor at the tip, that it's some tube that filled by a fluid. So that is inserted through the vein. Okay, the pressure exert and the fluid filled column is transmitted to external transducer. Okay, so when we inserting the fluid filled cathode tube in our vein, so that fluid absorbs some pressure, or it faces some pressure. That pressure is converted into electrical energy by external transducer. Okay, that is a fluid filled cathode type. Okay, this two type of probe is used to measure the blood pressure. See the diagram, and this is a sample stethoscope. Okay, stethoscope. So here this is our vein. So this vein is directly connected with the heart. Okay, so this is our tube, that is head cathode tube, that is inserted to the vein, and it is entered into up to heart. Okay, right. Then another end is connected with the sensor area. Here we are having the sensor, blood pressure measuring sensor. Okay, right. Then here and the blood is flowing through this tube. Then here we are having blood pressure transducer. Okay, so the transducer convert the blood pressure into some electrical energy. This is a monitor. Okay, so this is a diagram of direct method. So above diagram, the fluid filled head cathode is used. The better inserting and head cathode into blood vessels. The fluid filled system should be completely flushed out. Usually saline is used for the purpose. This will avoid blood clotting. Okay, so this method avoid blood clotting, so that the fluid filled head cathode is used in many direct blood pressure measurement. Okay, the next I'm going to see the circuit diagram used in the direct measurement. So here the circuit diagram has 4 sections. First one is a strain gauge, pressure transducer. This actually this is a bridge circuit. So one is a transducer that convert the pressure into electrical signal. Then this bridge is connected with the amplifier, that is a differential amplifier. It produces a high gain according to the change in electrical voltage. Then the output of the differential amplifier is given to the circuit. So that circuit sends two different things. One is diastolic, another one is a systolic. So the systolic pressure is indicated by this circuit, and the diastolic pressure is indicated by this circuit. Okay, how it works, let us see. Here M1 M2 is a meter, D1 D2 is a diode used in the diastolic indicator, D3 is a diode used in the systolic indicator. Okay, and the capacitor C1 and C2 C3, 3 capacitors are used here. Actually this is C2, this is C2. Okay, used in these circuits. Okay, let us how it works. The blood is taken from using the head cathode tip probe. The blood pressure is transmitted to the pressure transducer. Okay, then the output of the transducer is given to pressure monitor. The output of the transducer is given to pressure monitor. Because the transducer convert the pressure into electrical signal, it displayed in a monitor. Okay, it's a symbol. Okay, then how it works. So here the amplifier as a ECG system can be used. The amplifier as in ECG system, that is a differential amplifier is used. 2 indicators are available for display the system pressure, blood pressure. Okay, one is a systolic pressure and another one is a diastolic pressure. If output of the amplifier is positive going pulse, then D3 will be on. Okay, see the output of the positive going pulse, the D3 will on. So the capacitor C3 is charging up to peak value. Here R3 and C3 combination is used to set some time constant value, which used for stable display. See, understand, the amplifier output is positive going false, then D3 is switched on. See the circuit, D3 is switched on. Okay, here if it is positive means the positive signal is enabled, D3, that's a forward bias switched on, then capacitor is charges to peak value. Okay, the capacitor is charging to peak value, then what will happen, then of the peak value here, R3 and C3 combination is used to set some time constant. R3 and C3, okay, R3 and C3 produce some timing levels, some produce some time constant. Okay, time constant value which is used for stable supply. This is one state. Diastolic circuit shown the readings in indirect way. Initially the clamping circuit is available. The C1 and D1 are used to develop the voltage which is equal to the peak to peak value of the pressure pulse. Okay, D1 and C1, D1 and C1 that develop one voltage that is equal to which is equal to the peak to peak value of pressure pulse. These voltages appear across R1 resistor, then D2 diode is on, so C2 is charged up to peak value of the pulse signal. The diastolic pressure is displayed using the indicator 2. Okay, right? So meter 2, M2. M2 equal to peak systolic value minus peak to peak pulse pressure value. Okay, that is a M2. So this way they are measuring the diastolic pressure. Okay, right? So diastolic pressure, how it is measured, the voltage is developed by using D1 and C1. Okay, at the time the D2 is for forward bias. So the D2 is forward bias means the capacitor C1 is C2, actually this is C2 charging to the peak to peak value, peak to peak pulse value. Okay, so at the time that level is indicated by the M2, that is a diastolic indicator. So how the formula is M2 equal to peak systolic value minus peak to peak pulse pressure value. Okay, this is a important thing. Okay, right? So this way we can measure the blood pressure. So in blood pressure measurement, that is a direct method and indirect method is used. Okay, right? So direct method is used to measure the accurate blood pressure values. Indirect method is used to measure the blood pressure it's not accurate, but it is almost acceptable level. Okay, right? So the indirect method is normal method, it's a common method, but direct method is used to measure the blood pressure in some critical patients. Okay, right? So blood pressure measurement is also one of the important question in this unit. Okay, study well. Thank you.